In this video, we're going to be talking about different kinds of roots. We know about square roots. You might be familiar with cubed roots, but we can continue to go up and have really whatever number root we want to take. And to define all roots, we just give it a variable n and we call it the nth root. So for example, if we have our little recipe here, n is going to be our index. That's the type of root that we're taking. We can take any root of a number, a. So this is usually our base, right? So if we have a square root, normally you don't see that index. It's kind of an implied 2 there. You don't normally see it, so if it's not there, it's just implied that it's a square root. So that would be what a square root should look like if we included the index. And so we would say the square root of 9 is 3. If n was 3, so if our index was 3, then what's the cubed root of something? The cubed root of 27, for example, would be 3. 3 times 3 times 3 is 27. That would be the cube root. We could keep going up. These are the only two with special names, square and cube. From there we have the 4th root, and then the 5th root, and so on and so forth. I've never taken a higher power root than really the 4th root, but it is possible. You could take whatever kind of root you wanted of a number. So that's nth roots. We could also rewrite this in what's called exponent form. So real quick, let's just call this what it is. This is radical form, because we're writing an expression using a radical, so it's called radical form. If we write an expression using an exponent, it's called exponent form. So if I rewrite this exact expression in exponent form, I would say the base is a. N is my index. That's going to be the bottom or the denominator of our fraction. And since a is to the power of 1, then we would just write a 1 on top. We could say a to the 1 right there to make it match up a little bit better there, so you can visualize it. Whatever exponent our base has is the numerator when we write it in exponent form, and whatever number is our index is the denominator in exponent form. So square roots, where could I write this? I'll write it over here. This in exponent form would be 9 to the 1/2. There's our index on the bottom and our exponent on top. So if you ever see an exponent to the half power, that always means square root. If you see it to the 1/3 power, such as 27 to the 1/3, that would be a cube root. Now this number on top can also change. We'll get into that in a little bit. I just want to explore this nth root concept for a sec here. Let me get rid of this, keep talking about it. So if n, if that index, if n is, if it is an even number, such as a square root or a 4th root or a 6th root or an 8th root and so on, if it's even, then there's always going to be two real solutions or two real roots. But that's only if our base a is a positive number. So for example, here's our example. If I take the square root of 9, like we said, well, n is even, there's a little 2, implied 2, right? And a is positive, it's 9. then we have two real roots. If we're solving, this is if we're solving. I guess I should say that, to solve. So we would say that it's both positive and negative 3, right? It's positive 3 and it's negative 3. So there's our two real roots. They're real numbers. We got two of them. If, however, if n is even, but a is positive or negative, right? Well, then we deal with our imaginary numbers. Then we have two real solutions or two roots, but they're imaginary roots. So, for example, if we were trying to solve something and we were asked for the square root of negative 9, well, then we would know that the solution would be positive or minus 3i. So positive 3i and negative 3i. Alright, so we were asking that question earlier, what if this number on top here is not a 1? What if it's another number? Well, that's possible. We got a slightly different little formula we could use. So if this is any number, we'll call it m for any number there. Well, again, this is exponent form. Let's put it into radical form. The bottom number is our index, and we have a as our base. And really, what we do is we multiply all of this to the power of m. And we can also write it one more way. And this way may be helpful when simplifying sometimes. We can actually write this m instead of doing our exponent last. We could actually put our exponent in there if that helps us get a perfect nth root. So 3 ways of writing this right now. So get used to those, play around with those. Again, these two forms are basically the same thing. It just depends on what allows you to simplify the easiest or the best. So hopefully we'll see some examples of that in the near future. Let's do a couple of these right now. If I have 9 to the 3/2 power, in this form, in exponent form, maybe it doesn't make any sense. So if you change the form to radical form, it may help you simplify. So 9 is our base, right? 2 is our index, so we're taking the square root of 9 and we're going to cube it. So the square root of 9 is 3, and 3 cubed is 27. So 9 to the 3/2 power is 27. Now, as you can see, writing it in this first form here was a lot easier to do. Because 9 is a perfect square, ideally we would want to do that first. Cubing 9 first and then taking the square root of that would make a mess. A lot bigger numbers to deal with. Still possible, it's still going to give you 27. But you just have to deal with far bigger numbers. Let's try another one. This time let's try a negative power here. Let's do 32 to the negative 2/5. So here we have a different nth root. We have a 5th root. So change the form if it helps. We have 32 as our base. We're taking the 5th root of that, and we are doing the opposite of squaring it, taking a negative 2 power. So same properties of our exponents apply, and I'll show you exactly what to do with that in a second, but I think we can simplify the 5th root of 32 first, so we might as well do that. That would be 2 to the 5th is 32, so the 5th power of 32 is 2. We're going to take it to the negative 2 power. Well, a negative exponent means to flip it or do the reciprocal. Since this is 2/1, we're going to say 1/2, and we keep our exponent. So we've taken care of the negative exponent by putting it under 1. And now just simplify one more step. 2 squared is 4. So we get 1/4. We could have also done all of this on one step. So if we had gone from here and just written 1 over the 5th root of 32 squared, then we could have gotten 1/4 that way. Either way, a lot of times doing it one step at a time will help you keep yourself organized. Some of you may be able to just do this jump right here. That's okay. Let's see, did I miss anything? I don't think so. In our next video, I'm going to be re-emphasizing our exponent properties, just so that we're absolutely clear. They all still apply the same way, although dealing with fractional exponents may be new, so we'll just review our exponent properties this time using some radicals and some fractional exponents. Alright, see you then.